Hello and welcome everyone. This side Manish Sharma from Skillable India. In today's session of geometric dimensioning and tolerancing, I'm going to let you know about the 3 to 1 principle. Okay, so what 3 to 1 principle means and how we can apply onto the planar datums, okay, or the planar surfaces. And why this 3 to 1 principle is important. Okay, so one step by step, I will let you know. And in the previous sessions also, pretty much we have discussed about the 3 to 1 or the 6 degrees of freedom in or the 6 DOF or the for the part to get in a stable condition. Okay, if we want to get a part into a stable condition, we have to follow the 3 to 1 principle. Okay, so step by step we will be discussing this in very detailed manner. Okay, so you can see that we have two objectives when the mounting a part in a fixture or machining for machining. Okay, so wherever we are mounting a part, okay, this is a bed of a machine, and if we are mounting a part onto this machine, okay, so there are two objectives. First objective is accurately position the part at the desired coordinates. Okay, so whenever we are mounting a part onto a machine bed, so the first thing is that the part position in a correct way. Okay, so and the coordinates should be in a match. Okay, so desired coordinates should be achieved when we are mounting a part onto a machine or onto a fixture for machining. Okay, so first we have to, let's say this is a fixture. Okay, and we have to mount a part like this. Then the mandrel will come and do the machining on the surface of the part. Okay, so whenever we are putting onto this fixture, this part, we have to accurately position the part of the for the at the desired coordinates. Second is restricts all 6 degrees of freedom. Okay, so that the part cannot move. Okay, so the second very important thing is we have to restrict or we have to arrest all 6 degrees of freedom that the part can move and rotate. Okay, so we have to arrest all the 6 degrees of freedom that the part should come into a stable condition. For to arrest all 6 degrees of freedom, we have to follow 3 2 1 principle. Okay, so when you will add 3 plus 2 plus 1, this is 6. So this is 6 degrees of freedom. Okay, so this by adding 3 plus 2 plus 1, we will get 6 degrees of freedom. Okay, so basically 3 to 1 principle is related to the degrees of freedom only. Okay, now the most important part is a widely used method of accomplishing these two objectives uses 3 to 1 principle to achieve these two objectives. Okay, to achieve these two objectives, we basically use the principle which is called the 3 to 1 principle. So called because it entails three steps that employs 3, then 2, then 1 fixed points of known location. Okay, so first of all, we will, let's say this is a part and we have to make this part into a stable condition. So first we will lock or arrest 3 degrees of freedom, 3 DOF. Okay, which is a primary datum. Okay, first of all, in a primary datum, what we will do is arrest 3 degrees of freedom. Then we arrest 2 degrees of freedom in a secondary datum. And then we arrest 1 degree of freedom DOF in a tertiary datum. In the starting of datum, I have already told you. Let's say here again I am giving you one example of a feature control frame. Okay, so in the first compartment we usually give the one geometric characteristic symbol. Now we are taking the position symbol over here. Then we provide the tolerance. Let's say 0.1 mm of tolerance we are providing. Then we provide the material condition modifier. Let's say here I am using the maximum material condition. And in third compartment, fourth compartment and fifth compartment, this compartment is for the primary datum. This compartment is for the primary datum. This fourth compartment is for the secondary datum. And The fifth compartment is for the tertiary datum. Okay, so in the primary datum, we are arresting three degree of freedom. In secondary datum, we are arresting 2 degrees of freedom. In a tertiary datum, we are arresting 1 degree of freedom. Okay, so one by one, I will let you know that how these degrees of freedom are arrested. Okay, and how we can put the part in a stable condition onto the bed. Okay, or onto the fixture where we are going to do machining. Okay, if we will not make a part into a stable condition and we start machining onto the part, let's say, okay, so the part will move with the machining. Okay, maybe it can move like this, it can move like this, it can rotate. Okay, if the part will not be in a stable condition, then when we will machining onto the part, it will, the coordinate gets disturbed. Okay, so to lock, to arrest all degrees of freedom to that coordinate, whatever we are coordinate we have set. Okay, so for that we need to arrest all the 6 degrees of freedom with the help of 3, 2 and 1 principle. Okay, now move on to the second part. So in order to completely specify the position in a space of a three-dimensional, okay. So here you can see in this example, that the part is in a space. Okay, the part is in a space. So we are considering that the part is in a space of a three-dimensional unit. Okay, so three-dimensional x, y, and z axis. So whatever x, y, and z axis. So we are considering the coordinates, okay, and part is into a space somewhere here, okay, which is not at the origin, which is 0, 0, 0. So the part is not at the origin, it is into the space, okay. So if we want this part to be in a stable condition, we have to lock the 6 degrees of freedom, okay. So with the help of 3D object, I will let you know each and every detail that how you can do this. So object such as a cube that's shown, we refer to the 6 coordinates. Okay. So what are degrees of freedom? 3 are translational. Okay. The part can move into the x-axis. The part can move into the y-axis. The part can move along the z-axis. Okay. So part can move upwards, part can move this side, and part can move in a this direction. Okay. So x, y, and z direction the part can move. Now, 3 are rotational. Okay, 3 translational movements are there and 3 rotational movements are there along the x-axis, along the y-axis, along the z-axis. Okay, so along the axis, it can rotate x-axis, y-axis, and z-axis. Okay, so these 3 are rotational. So these total means 6 degrees of freedom. Okay, these 6 coordinates are known as the 6 degrees of freedom of the three-dimensional object. As the double-headed arrow indicates the translational movements, you can see this is a translational movement, this is a translational movement, this is a translational movement, this is a rotational movement, this is a rotational movement, and this is a rotational movement. Okay, so if we are considering, let's say x, y, and z, and this is if we are considering x, y, and z. Okay, so 3 are rotational and 3 are translational movements. Okay, can vary the either direction with respect to each of the 3 axes. Okay, so to completely prevent movement, all 6 degrees of freedom must be restricted. Okay, this is very important, and we will be knowing this in the SolidWorks example. Okay, so I'm closing this and opening a example over here. Okay, let's say this is a part. Okay, so we are considering this part. Okay, so this is the part and we want to make this part into a stable condition. Okay, so you can see I have given this part a spherical shape. Okay, why I have given? Because when it is touching to the surface, whenever a spherical part will touch to a surface, it will touch via point. Okay, so it will always have a point contact. That's why in all the part I have given a spherical surface that it is going to make a point contact. Okay, so let's say if I want to put this part into a stable condition. So first of all, let's say I will put 1 point. So first says 3 to 1 principle. First we have to restrict the 3 degrees of freedom. Okay. So this is a primary datum. Okay. With the help, this is a primary datum. And if we want to restrict the part, so first of all, I will give 1 point. Okay. Now you can see the part is not in a stable condition. Okay. Although 1 point is touched in this part, but it is not in a stable condition. Okay. If we will see from the right view that it is touching at the 1 point at from this part, but still it is not in a stable condition. Okay. So minimum why now I will provide the second point touching this datum. Okay. Now I have provided the second part touching this datum. Okay. Now you can see that still the part is in a not in a stable condition. Okay. So thirdly, we will put again third point. Now we have touched 3 points of the part with the primary datum. Okay. So now I have touched 3 points of the part with the surface. Okay. So these 3 points are touching the surface. So first of all, in the primary datum to stabilize the part, we have to provide at least 3 points. More than 3 points are very good. Okay. There can be any number of points, but minimum requirement to stabilize a part is of in the primary datum is of 3 points. Okay. So this is a 3 point contact for the primary datum. If we are considering as a primary datum, so I have provided 3 points in this. You can see that it is touching there, here, and here. Okay, these 3 points are touching the surface. So now you can say this part is in a stable condition. Okay. Now in the secondary datum, we have to provide 2 degrees of freedom. So in this condition, now this part, if I will make this on, okay. So what happened? The part cannot move in this direction. So one translational movement at y-axis. You can see this y-axis over here. So now the part cannot move in y-axis. Okay. Part cannot rotate in this axis. Okay. So in y-axis, the part cannot rotate. The part cannot rotate in the x-axis also. Okay. The part cannot rotate in the x-axis. And part cannot, the 3 degrees of freedom are locked. Okay. Now what other 3 degrees of freedom are left? Okay. The part can move in the z-axis. The part can move in the x-axis. Okay. And part can rotate along this center axis. Okay. So one rotational and 2 translational movements are remaining. Okay. So first of all, to restrict the secondary datum, we have to give 2 degrees of freedom. Okay. So again, we will provide 2 point contact with this surface. Okay. So first of all, this. Okay. Now you can see that still this part having the movement like this. Okay. So to stabilize this part, we have to provide the one more point of contact with this part. Okay. Now 2 degrees of freedom in the secondary datum. When this is the secondary datum, this is the primary datum, and this is the secondary datum. Okay, we have provided. So by applying secondary datum, we have restrict 2 more degrees of freedom. Okay. Now you can see the part cannot rotate in any direction now the part cannot rotate in this direction also. Okay. And what other movements is restricted? The part cannot move in the z direction also. Previously part can move in the z direction and rotate along this axis. Okay. But now these 2 movements are also restricted. Now only 1 degree of freedom is left. The part can move along the x-axis. Okay. So to restrict this movement, we have to provide for tertiary datum. This is the tertiary datum. Okay. And we have to give 1 point of contact. Okay. In the primary datum, we have restricted 3 degrees of freedom. In the secondary datum, we have restricted 2 degrees of freedom. And in the third part, tertiary datum, we are going to restrict the last degree of freedom, which is the movement of x-axis along the x-axis. Okay. So I am giving one point of contact like this. Now this part is fully constrained and fully in a all the 6 degrees of freedom are restricted. Okay. Now this part cannot move in any direction. You can see all the degrees of freedom are there. You can nor it can rotate in this direction, nor it can rotate in this direction, nor it can rotate in this direction. Not it can move in this direction, not in this direction, not in that direction. Okay. So all the 6 degrees of freedom are restricted or arrested with the 3-2-1 principle. Okay. So this is the very important thing. Again and again I am saying it is not required. The minimum 3 points are required to arrest first of all. Okay. So more than 3 there can be any number. Minimum 3 points are required to make a part into a stable condition in the primary datum. Okay. So this is the first part. Now the question arises. Okay. Can we make a cylindrical part with the help of 3-2-1 principle? No. Can we make a conical part with the help of 3-2-1 principle? No. Why it is? Because in the previous section, I have already told you about the datum feature simulator. Okay. So when we have to arrest the degrees of freedom of a cylindrical part, let's say this is a shaft. Okay. And if I want to arrest a degree of freedom, so it is not going to, not going to fit onto the planar surface. I am going to arrest by moving a cylindrical datum feature simulator only. Okay. So I have to provide the cylindrical part to arrest the all degrees of freedom of the I will say cylindrical part. Okay. So only that's why the 3-2-1 principle is only applicable for the planar surfaces or the planar parts or the part which need to be arrested in a that condition. Okay. If there is a spherical part, okay. So how we will arrest the spherical part of this? Okay. So I will say if let's say this is a spherical part. Okay. So there are two conditions. If I have to make this spherical part, which is a ball in this case, to in a stable condition, what I have to do is I can provide the 3-point contact. Okay. If I will provide the 3-point contact and if I will give the datum targets in the coming section, we will understand about the datum targets in very detail. So if we give the datum targets, okay. So with the help of 3-point contact, we can restrict all 6 degrees of freedom. Okay. So in this part, we can check the 6 degrees of freedom in a very detailed manner. Okay. And the second thing, to arrest all 6 degrees of freedom of this spherical part, I can give a spherical datum feature simulator. Okay. So if there is a simulator which is datum feature simulator of a part which is into a spherical shape, so I can lock all the 6 degrees of freedom. Okay. So this is how we provide the, this is why we understand about the datum feature simulators. Okay. Now we will move on to the next part. I will give you brief understanding about this. Okay. So while giving example, okay. So you can see the chair. I am giving you an example of a chair. Okay. If I want to make a stable, at least 3 legs are required in a chair to make into a stable condition. Okay. One leg chair will not sustain. 2 leg chair will also not sustain onto the floor. At least 3-point contact is required for the chair to come into a stable condition. Okay. So this is the primary case. Okay. More than 3-point contact is very good. Okay. We also know we have 4-leg chair. Okay. We have the 5-leg chair also. Okay. Available, which is into the base. Okay. In which the casters are there. Okay. Movable chairs. So in that case, we provide more than four arms for the stability of the chair. Okay, so these are the cases where minimum 3 points of contact are required in the primary datum. More than three datum, you can give any number of points of contact. Okay, let's say in this case only you can see that there are six legs in this table. Okay, if the length is much more bigger, then we have to increase the points of contact of that part. Okay, so that's why it is just an example that why we need 3 point of contact to get into a stable condition. Okay, so here is it is an example of a table. For table also we require at least 3 point of contact. Okay, more than three, it is a very good number. Any number that is touching. So let's say this is a table and this is a part. Okay, the part can have ups and downs like this. Okay, so maybe these are the three top points of this part. Let's say, okay, so here you can see that three top points will touch the surface, and more than three, any number of point can touch the surface. Okay, so to make this part onto this table, if we put this part onto a table, at least 3 point contacts, minimum 3 point contact is required. More than three, any number of, there can be 100 points, there can be 1,000 points. Okay, or the whole surface should be there. Okay, minimum 3 point of contact is required to make part stable in a primary datum. 2 point contact is required to make part in a secondary datum stable, and 1 point contact for to arrest all 6 degrees of freedom in the primary datum, secondary datum, and tertiary datum in the feature control frame. Okay, so this is all about the 3-2-1 principle. If you have any confusion, you can write it down to one note section. Okay, we will definitely try to give answer. Trying to give you answer. In our book, we have shared this in a very detailed manner. If still you have confusion, you can ask us. Okay, so this is all about the 3-2-1 principle. Thank you. Thanks a lot.